Hello, everyone. Today we are going to resume our discussion on using Shiny modules. We left in the section of inputs and outputs the last time, and there are three exercises after that section. To save some time, I'm going to only discuss exercise number three. So let's first look at the question for exercise number three. It says the following module input provides a text control that lets you type a date in ISO 8601 format, so it should contain year, month, and date. Complete the module by providing a server function that reduces the error that uses the output error to display a message if the entered value is not a valid date. The module should return a date object for valid dates, and for that they give a hint to use a strip time function. So here is the UI. This UI takes two inputs, ID and label. And with these two, it first creates a label with the information that it should contain this format. And then within a fluid row, we have the text input. This is where we provide the date, and then an action button, which is optional, and then a text output that should contain the error. Now let's look at the server part. So this is the solution to the exercise. So we first create a reactive expression that takes in the input date and then uh, convert it into a date format, and we make sure that it is in this format. And then we say that if the result is NA, then we should get the result as null and then return that result. And this is bounded by the event of clicking the check button, which is the action button as shown before. And this is optional. If we don't provide that, it would respond right away. And then the error output is a render text, which checks if the date result is not null, then it returns null. I think this is probably a typo. Here we're using this uh, because running this app uh, doesn't produce the expected output. So we get the date app. This is for experimentation where we create a UI with the date UI, and what with using YMDate server we create a server, and then here's an example of the Shiny Live uh, app that's embedded in these slides. So if I run this app, we should see an error if I provide the date in the wrong format. So if I say that the year is 98, then these month and date values, and I confirm date, we don't get any response, although this is incorrect. If I provide the correct one, here we also don't get the response. I think there is some error, some mistake that we are making here within the error function. I tried using a different way, but perhaps this needs to be changed, although that's what the hint says we should do. So if anyone has any ideas, please let us know. All right, so after this, the slides are complete, and we have some links to examples, but there is some part of the chapter that's still left over. So if we go back to the chapter after the inputs and outputs section, in chapter 19, we have case studies where we have three examples, limited selection, wizard, and dynamic UI. So today I'm going to show you quickly how these different aspects of creating Shiny modules work. So the exercise 19.4.1, not the exercise, the section 19.4.1 is about creating the Radio Extra app. And this is where we are using limited selection plus the other option. So let me first show you how the app works. I'm going to restart my RStudio session and then source this app. And at the end, I have this option to run the app. So on the right-hand side, we have the app running in our studio, and we see that we have this question: how do you usually read CSV files? And we have these three options. But there's also this additional option, which is a text input. So this is in addition to the radio choices here, and then the text input. If I choose something else, you can see that as I was typing, it automatically selected the other option, and it also tells me that it is properly selected. So let's dig into how this was created from the UI side. So for the UI version, UI part of the module, we call it as Radio Extra UI, and we are providing it with multiple arguments in the function. So the default is the required um, argument is ID, but we provide more. So we provide one for the label, we provide the choices, the selected, which is null as default value, and the placeholder. So this is a placeholder. If I refresh the app and run it again here, you see that other is the placeholder. And here's how it is created. So first we create this text input that's on the right, and we namespace the ID, and we give it an ID of other. The label here is null, so we don't want a separate label for the text input. The placeholder will be what we provide here, which is shown here. And then we then look at the choices that are provided. So the choices you can provide as a list, which could be a named list, or you can provide the choices as unnamed list or just a vector. And if there are no names for that choices object, it will just return choices. Otherwise, it will return the names of those choices. And then we take the choices object and unname it and to get the values of the choices. So now that we have the names and the values of those choices, now we can create a radio buttons object. We also namespace it with its with the ID provided in this function, and we the ID for this radio buttons is primary, and we provide the label. This is where we use the label, and that's where this label is coming from in the example. And the choice values are now the names, and one additional name is other for this other object or text input. And the choice names are values which are first converted into a list. So these are all the choices. So these are these three choices in this example. And the fourth choice is the list other, which can change. It can vary depending on what the user types. And the selected by default is going to be null, but we can provide any selected value here as a developer. The server side uses module server, and with an observe event, we check if the input other has a value, which means that if we type something here, then we update the radio buttons, and the radio buttons thing that we are updating is the primary one. So we use that ID here. We make sure that we are right within the same session, and we select the other one because something is typed. This is why when I type, then this is selected because update radio buttons is running. And then we return the value which is provided here, whether typed or selected. This is going to be uh, the returned value from the server. As you can see, it is returning a reactive object, and it checks if the radio button has a value, selected value of other, then it will select whatever the value of this text input is. Just to remind you, the ID there is other, so that value is selected. Otherwise, it will select out of the three choices that we have, or any number of choices that we have in the radio buttons right here. And here is just an example of how to use the module UI and server. So we provide radio extra UI, and here we use dot 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 because we want to be able to provide any number of arguments to radio extra UI. and the server uses radio extra server module, part of the module, and returns, as we have seen here, a reactive object that contains the answer, the selected response, and we call it as extra, and then we return that in using render text, and that's why we see this uh, in the app. And here, because we have provided dot 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 in this function for experimentation, we are able to provide label and choices. Okay, so the next part of the our next case study is on creating a wizard. So a wizard app is something that can be of multiple pages with the next button and the previous button, and it will change the page. So it will act like a wizard introducing the app to your users. To create such an app, we need to do a bunch of steps that we need to take. First, let me restart the session and then run the app to show you how it works. And then we'll later dig into uh, what are the steps to make it work. So the first page of this app says, what's your name? So I enter a sample name, click next. Then how old are you? So I change the age. If I click previous, I see the same input, and it doesn't change here when I go to next. When I click next, then it tells me that this is the data that's been collected so far. And then there's the previous button again, so I can go back, or the next button, so I can go to the next page, and then I can submit. So before I submit, I want to show you that we have two next buttons. So this is the first one, and then this is the second one. And we have two previous buttons, so previous and previous. On the first page, we don't have a previous button. And on the last page, we don't have a next button. So notice that. And also, if we go to the first page and we look at the ID of this button, I'm going to right click. I am in Firefox. I'm going to click on Inspect. And here we see that the button ID is demographics go _1_2. Now the label of the button is next, as we see here. And now I look at the second next button. And now the ID is demographics go 2_3. The previous one was demographics go 1_2. So 1 and 2 and similarly 3 refer to the page numbers. And although the button appears to be exactly the same, uh, they're actually different buttons because they have different IDs. And now I'm going to click on submit. And this shows me, thank you, that the wizard has completed. I'm going to stop this, restart our session, and then let's see how this app is built. The first thing is we create some helper functions. There are three helper functions here. One for creating the next page. This helper function is going to take ID. So since we are creating different UI elements, for each UI element, we need an ID. That's why a function that creates that element also requires ID as an argument. And the second argument here is I, and this refers to the page number on which this button would be. And inside the function body, we see action button, and we use the ns function to namespace our ID. And the way that ID is created here is using page 0. And we have a prefix, which is go here. And then we have I and I+1 to refer to the page number. So I showed you that for the first page, the ID was go _1_2. And so we have go underscore, and I will act as a page number. So if you're on the first page, it should be number 1. And when you click on it, it should take you to page number 2. That's why this should say go _1_2. Similarly, for the previous page, we have go underscore I minus 1 instead of I plus 1. The labels for the next and the previous buttons are using their names, next and previous. So this is how we can create next and previous buttons for each page where we want them to appear. Then we create another helper function, which is the wrap page function. And it also has a number of arguments as inputs. The first one is the title of the page. The second is the page number, the page content. And the third and fourth arguments have default values of null. These are the button left and button right. The reason why the null values are used here are because um, we have uh, uh, we have some pages where we don't want the previous button to appear. For example, on the first page, we should not have a previous button. Similarly, on the last page, we should not have a next button. So that's why the default values for these buttons is null. Now let's see how the wrap page function works. So we have tab panel here. If I look at the documentation for tab panel, we see that it takes in a title and some UI contents, and the value is equal to title. So that's what we do here. We provide title equals to title, and then in the remaining of the tab panel, we create UI contents, which here we are building using Fluid Row. But the tab panel can only be used inside a tab set panel. So a tab set panel will formulate a structure of the UI where we create individual panels using tab panel. But what you see here is just the tab panel function. It is not wrapped in the tab set panel as I show here in the documentation, which means that we need to use the wrap page function inside tab set panel, as we'll see in a moment. So again, within each tab panel for each given page, we will have the page title. We'll have the page contents in the first row, which is taking the full width of the page. And in the at the bottom, there's another row which will contain on the left button, and on the right we have the button underscore right. So let's see how we use this wrap page using the module UI. So for module UI, we name it as Wizard UI. And with Wizard UI, we have three arguments to the function. ID, as we know, is required. Pages is another argument. And then the done button is another argument, which has a default value as null. So done button is on the last page, we need to have a submit button. So this refers to that. First, we check uh, if the pages thing that we provide here, if it's a list or not a list. If it is a list, then uh, we go to the next line of code. If it's not, then we stop that right there because the pages thing should be a list, because this is where we provide a list of page contents. And then the second line here is going to look at the number of pages. So it could be 3 pages, 5 pages, whatever number of pages you want to use for your wizard. Then we create a empty vector that we call as wrapped. Let me show you how that works outside of Shiny first. So if I run wrapped list and instead of n I provide 5, it will create a list of 5 null values. So we start with a vector, or actually a list, which has null values, and we are going to fill in each page with the contents of that page. So we say for I in sequence along pages, so we know if there are 3 pages, I will be 1 to 3. First page only has next button, and the last page only has previous button plus the done button. So now we look at the page number, and using that information, we provide the relevant contents and the button. So we check if I is greater than 1. If I is in fact greater than 1, that would mean that we are not on page 1. Then we have the left-hand side as the previous page. Remember, the previous page function comes from this function that takes the ID and the page number. So here we provide the ID, and the ID is coming from the wizard UI, and we then also provided page number. Now, since we are going to create a number of previous page buttons and a number of next page buttons. For each of them, the ID should be unique. This is why in the functions next page and previous page, ID and I are combined to create the ID for the action buttons. So now they have unique IDs. So if the page number is more than 1, then we do have a previous page, and we call it as left-hand side. And if it doesn't, then we do not create it. And on the right-hand side, we want to create the next buttons. So if the I is less than n, and imagine that n is 3 pages, so it is 1 or 2, then we will have a next page appearing on those next page button appearing on those pages. It also uses the ID that we give to wizard UI and the page number. And if it is not less than n, that means it's greater than n or equal to n, then we use the done button, which will be the right-hand side. Obviously, greater than n doesn't make sense here because there won't be any page more than the n pages. And then once we have the left-hand side and right-hand side for a given page, we then take our wrapped list, which, just to show you, again, is a list of null objects in the beginning. And for each page, we are going to use a wrap page function. And just to remind you, it takes in the title of the page contents, button left and button right. So we provide the title of the page, which we call as page underscore. I would be, for example, 1 in the first iteration of the loop. So it would be page underscore 1 as the title. And then the second argument here is the page contents. This is where we provide pages and with the ith content. And so this is actually the input to the wizard UI. So this we need to do after we have created the wizard UI and the wizard server parts of the module. Then when we are creating the app, then we provide the pages list. So we take the pages list and then the ith element, and that will provide us the pages content. And then we provide the left-hand side and the right-hand side, which are essentially the buttons. So once we have everything done for the given page, we also add to this wrapped list, we also add the ID of the wrapped list. So we add this additional attribute to this list, which will be a namespace ID called wizard. And then we also provide the type, and we have this as hidden. And then we use do.call, and this is where we use the tab set panel and provide the wrapped object. So remember, wrapped object is actually a list. Initially, it is all null values. So imagine there are 3 pages, so there will be a list of 3 null values initially. After this loop has run, it will contain the left-hand side, right-hand side, and the page contents for a given page I. And once we have everything done, for that, remember, wrap page is using tab panel. So we have in our example of 3 pages, 3 tab panels, just like this. We'll have 3 tab panels created. Now, since we have to wrap this with tab set panel, this is what do.call is doing, and we provide it with wrapped. But the do.call is required here because tab set panel does not allow entering the list of tab panels. You have to provide tab panels this way. it won't work if you provide a list of tab panels. So that's why we use do.call, and that's why we also provide the ID to the wrapped object, the list wrapped, and the type. We tell it that the type is hidden, and we give it an ID of wizard, and then we use do.call with it to create a tab set panel with all the tab panels coming from the wrap page. And then within wizard server part, we have a change page function. The change page function, as we notice from the name of it, is going to change the page when we click on a button, next or the previous. So here we take from and to refer to the page numbers. So we say observe event, and what are we going to observe? We're going to observe the action from a button. And if I run this again, just to remind you how that works. So we have the next and the previous buttons. So these are the actions that we want to use. But remember, for each next and previous button, the ID is different, but we do know the structure of those IDs. So within the server, within the change page function, we say observe the action from this button, and that button could be any button out of all of these. So we say paste 0 go underscore from underscore 2. So if we say from is 1 and 2 is 2, then it would say go underscore 1 underscore 2. So just like how these are created here, go underscore 1 underscore 2 or go underscore 2 underscore 3. This will refer to all of those buttons that we have created. And once any of them is clicked, what it would do is it will update the tab set panel, which means that when I click on next here, I'm not actually changing a page, I'm just updating the tab. So the tab set panel is updated. We refer to the object wizard. Remember, that's coming from here, this ID. And then we also have provided the selected part, which will be the page underscore 2. And so based on that, and just to see, the page underscore 2 is actually referring to this ID for the wrap page. So this will update the panel for us. And now this is just the definition of the change page function. This is how we use it. So here we first get all the IDs. So with sequence length, we take the n number of IDs, which is coming from wizard server input argument. And using lapply, we first look at the IDs object. So this contains all the IDs, page 1, page 2, page 3. So we have 3. And then it will first look at the first one. And then if I show you what that means here, is that, or if I create, for example, x as 1, 2, 3. So we have x, which has 3 values, 1 to 3. If I say x, and then within square brackets, I say -1, it will remove the first object and keeps only the second and third. So we say, so remove the first page, and then using this function, we say change the page I -1. So this is going to change the page by, when we click on the previous button, it will go to the previous page. So it will use the function change page to go to the previous page. If we say IDs -n, that would mean 3 in our example. So for x3, we get 1 and 2. So then it will take the function I and change with I +1. So this is used to go to the next page. So once we have wizard server also provided, now here we are testing with the wizard app. Here we are not providing any inputs. So let's see how we are making a test, how we are creating this sample app. So the first page contains a tag list, which only contains a single input. The second one contains another input, which is the age. The third one produces the information output and also asks us if this data is correct. And so based on that, we then use Wizard UI. We provide it with the ID demographics. That's why if you recall, when I was looking at the inspect tools in Firefox, it showed me demographics underscore go underscore one underscore two for the next button. And here is the list of the pages. So we have pages 1, 2, and 3 created here. We provide it as a list to Wizard UI. And within done button, we provide the action button. So remember, done button is part of Wizard UI, which by default is null, but here we do provide a done button. And so once that is provided within the server part, we use Wizard server and tell it that there are 3 pages, depending on the 3 pages, the list of 3 pages. And then for the done button, once it is clicked, we just create a dialog box that says thank you. And this is now using the information output, which is essentially getting the age and name from the inputs. And that's why once we run this app, we get the outputs that we get. So running this again, we can go to the next page and go to the previous page, and then we click submit, we get thank you. So this is a very nice way to use the Shiny modules to create any number of pages for a visit, and it's, I believe, very powerful way to use Shiny modules. The last example here is dynamic UI, where we want to be able to create the UI dynamically because it varies. It could change, for example, depending on any value from a database. So you're not creating the UI within the UI part of the module. You're actually creating it within the server part of the module, and then rendering it in the UI part. So I'm going to stop this and restart my session. And in this part of the app, we have the module UI, which is very simple. It's just a UI output function that's used, where we namespace the ID of the output as controls. Remember, here we are using the per package, as I'll show you in a moment, that we are going to create multiple objects using functional programming. So here we have some helper functions to create this app. So I'm going to first run this app to show you what it looks like. So this is an app that we have previously created within, I think, chapter 18 or chapter 19. And then this one has an option to pick a data set and further options to change the values of multiple uh, multiple variables from that data set. So in this case, we have the air quality data set, which has all of these variables, and we can change the values of these variables by using these slider inputs, and then we get the data depending on what is the range that we have selected. So if I change that, change this, you see there's only a single row selected. And if I change this to another data set, we now have different variables. So for each of them, we can change the sliders and see a different output in the resulting table here. This is an interesting app where we could have multiple data sets, and you can basically use it to explore the different data sets. Let's see how it works. So as I said, for the UI module part, we just have a UI output, and we then have some helper functions that will help us create the server part, because that is where we are actually going to build the UI. So we have the make UI function, which takes 3 arguments. It has X, ID, and var. X is the variable, So we check if the variable is numeric. If it is numeric, then we first calculate the range, and then based on the range of that variable, we create a slider input, as we saw in the app, with the minimum value, the maximum value, and the selected value. But the variable could also be a factor. If it is a factor, we first check what are the levels of that factor variable, and then we create a select input instead of the slider input, and we provide it with the ID, which comes from the ID as the function argument, the variable that we want to show as the label. So if we just remind ourselves that if we look at the select input function, the second argument is label. So the var here is just the label of the variable. The choices are the levels that we have created here. The selected value is also the levels, and multiple is equal to true because we could have multiple selected as one of the options of select input. And if they're not numeric or not vector variables, then we simply do not support it, and we return a null value. This is the make UI part for the variable section. Then there is also a filter var function that we create as a helper function that will check the value of the variable and then filter the data for us. So we have two arguments, x and val, and we first check if the variable is numeric. If it is numeric, it will essentially return us a true or false in this function. So if it is numeric, it will first check if the value is not NA. At the same time, if the value is if the value of x is more than the value of the first value in the val, and it's less than the second value in the val. So val will contain the minimum and the maximum for that variable. And then if we check if it is a factor, then we check if x is part of the val. And otherwise, we don't control anything and simply return true. So as we see, this is either going to return as true or false. So with filter var and with make UI, now we are ready to create our server server part of the module, and we are basically building a UI here. So we first take in two arguments, ID as before, and the data frame. As we saw in the app, we can use multiple data frames. And we first check if the data frame is reactive or not. So we assume that this should be reactive because we are going to provide it with reactive data frames. So if it is not, then we'll stop the app right there and provide an appropriate error. Now within the module server part, we first look at the names of the data frame, convert it into a reactive expression, and then we use the output controls. This is, remember, the actual UI output. This is where we would render the UI. And with render UI function, we are now using functional programming. The map function is used from the per package, and we take all the variables. So these variables are coming from all the names of the data frame. So if the data frame is air quality, we have the variable names as ozone and so on. If it is a different data frame, then we have different names. So depending on what names we have, we take all of them. And for each variable, we use this function. So what we are doing here is we are first creating a UI for that for that function, and that's the only thing actually that we're doing within this map function. So we have we need to provide all the arguments for make UI, which are x, the variable itself, the ID, and the label of the variable. So we take here x, which is the variable. So we take df and then var. This will select the variable for us. The second is the ID. So remember, we need to namespace the ID here. and we namespace the ID here because we are building a UI. But remember, we are doing that inside a server function. This is the first time we have seen an example of that where we are creating a namespace ID because we are creating a UI and then a server module server function. And then finally, we provide the name of the variable as we know that a vars is actually containing the names, and this is what we are using here as a single var. So this will then render our UI, and then we return in this server part a reactive object, which will again use functional programming to take all the variables and apply this function to them. It will first filter the variable using a filter var function. The filter var function also takes two arguments, x, which is the variable itself, and the value of that variable. So here we provide the x, which is the variable, and the input, which means the selected value of the variable when slider input or select input has been used. And so we get the each var, and then we use the reduce function on each var so that we apply the and function to each of the filters that we are building using multiple variables, because for each variable there's either select input or slider input that has been used from the UI side, and they have multiple different values as we use here. So we then need to combine all the filters, and we do that using reduce and return that as a reactive object. So here is for our experimentation. We have this small app where we first provide the dataset input, and we say is.data.frame as a dataset input. Remember, dataset input is coming from the let's see. We do have the filter UI right here, make UI, filter var, filter server, and the dataset input is actually coming from the other functions that we have previously used in our previous discussion. So if I see here, right here, so this is where dataset input is, which essentially it takes in an ID and the filter. So we provide the ID as data, and the filter is that it should be a data frame. The other option is to make it to use is.matrix. Then we provide text output, which we provide an ID of n, and then filter UI, which is essentially this thing that is basically a UI output. And so in the main panel, we provide a table output. Now, since filter UI depends on the filter server function to build the UI for us, we then take in a DApp, which is coming from a dataset server. Going back to our example, dataset server basically selects the functions from the datasets from the package datasets, just to remind you from our previous discussion. And then based on the returns data frame reactive object, we provide filter server the DApp object, which is a reactive object or reactive expression. And now that we have the filter and the DApp, we are ready to create a table, which is the table output. So we do render table provided with DApp filter. And similarly, we also have output n, which basically contains the number, the sum of the filter. So we provide that here, and if I run this again, we get this, where we have multiple different data frames. So remember, this is the factor variable, so we have this option to use select input and slider input. And so for each of them, we can create different, we can select different variables, and we can select different values for them, and we get the output as we have used here for the table. So again, using Shiny modules is very powerful to, as we have seen in these three case studies, which are very involved, challenging, but if we were to not use modules, doing this would require a lot more code. The final section of this chapter has a small discussion on single object modules, which is where the author says that we have previously used this example, histogram UI and histogram server. Since we use histogram UI and server both, if we are creating multiple instances of the same module, we need to provide the ID and the data frame object for this example. So we need to repeat it. For histogram UI, empty cars, we have to do histogram server, empty cars. Looking at this, and people who want to reduce the amount of programming would think or agree with the author here that why not we just create a histogram app that basically returns a list of the histogram UI and histogram server. Uh, on the face of it, it looks a good solution, but the problem is and when we try to use it, we first create the histogram apps separately using this function outside of the Shiny. So this can go in the global part of the Shiny app. And then we then get the UI and the server part using this syntax. The problem is that this is not going to work because the module server, which is part of histogram server here, this thing should be inside a server function, the main server function. So this is not going to work. That's a problem. And the main point here is in Shiny, UI and server are inherently disconnected. Shiny does not know which UI invocation belongs to which server session. You can see this pattern throughout Shiny. For example, plot output and render plot are connected only by shared ID. So if we provide the same ID, then they're connected. Writing modules as separate functions reflects that reality. They are distinct functions that are not connected other than through a shared ID. So we need to keep them separate. And instead of using this solution, the right solution here is actually this is the correct solution where we provide histogram UI and histogram server, the corresponding server in their own sections within a UI and the server functions of the main app. So this completes chapter 19. In chapter 20, we are going to utilize these packages to create an R package for our Shiny app. Thank you.